Alright, hey guys, welcome back. It's been a while since we had this YouTube video, right? So today I've actually thought of talking to you guys about this concept of rate limiting. The reason is, so we're seeing a lot of public facing application booming, right? You can take an example of ChatGPT. Though ChatGPT has an application, people still prefer to use their API so that they can build their own solution on top of it, right? So when you're building such solutions, right, your first preference should be implementing safety measures as well for your APIs, because your APIs is good, but it also has to have some safety measures, correct? So one of the approach is using rate limiting so that you can limit based on certain strategies. So let's see those strategies. So before actually getting into code, I'm going to show you some of the strategies. Okay, so here we go. So these are one of the two strategies that many people follow. The first one is called bucketing and the second is called sliding window. I didn't get proper icons here. So in the bucketing, you provide quotas per 24 hours. You can say, okay, you can do 300 requests per day. Okay. In sliding window, it's more lenient. We can say you can do 20 requests per minute or 100 requests per hour, or let's say 10 requests per second, something like that. And this particular decision is up to you. You can decide whatever works for you, but these are the most common strategies people use. Okay, and let's see how to implement them. Implementing any of this thing is really easy. It's just some math functions, that's all. Okay, but implementing them is really simple. But let's see some of the strategies that you have to follow and some of the caveats you have to keep in your mind when dealing with rate limiting. Okay, the first one is I have a few APIs here. Let me introduce you to the APIs. One is simple get API, all are get APIs. One is get all, which returns all the users. Users are simple JSON objects I have in the file. Okay, and another one is it will find the ID of the given user. If it doesn't, it will just give you empty object. And the next one I have is a API key generator. It gives you some random keys. Okay, so let's try it out. So here I'm gonna say key and then I'm gonna just send it. So we get some random API key here. Okay, and then let's request the next one. So that is the get all the users. So I'm gonna just send a request to all the users, and there we go. We have all the users that we're getting. Okay, and then we have one more API that is to get user by ID. So here I'm gonna give ID, let's say 1, send it, and there we go. We got the first user. So all the APIs are working fine. Now think about this. Now we have to rate limit, right? So finding finding one user from all the user is a bit of expensive task, right? Let's say you have 100 users, you have to find the 100th user. Then it's a bit of an issue, right? If you don't have any index or something like that. Let's not talk about indexing and database optimization here. We'll just think like, okay, it's a complex mathematical function and then we want to rate limit the users. Okay, how can we do that? The first thing that we would do is one of the thing that I usually see people doing is people use IP addresses to track the quotas. Don't do that. I mean, it's fine if it's a small project or something, but when you're implementing for some corporate level project or production grade project, don't rely on IP addresses. The reason is, see, if your customers are corporate businesses, right? Let's say many of the ChatGPT's customers are businesses as well. Again, these businesses will have NAT gateways. So what it does is, whatever the request their system is generating will be masked to a single IP address. If they have 10 system sending a request to ChatGPT API, okay, with the different IP addresses, all those different IP addresses will hit to a NAT gateway. That NAT gateway will change that IP address, will mask that IP address to a same IP address. So for your system or your server, all those 10 requests will seem like coming from a single server, single system, though they are from a different 10 system because they are masked, right? That's the reason. Do not rely on IP addresses. Okay, what do we rely on? We rely on API keys. So all these 10 systems, they need to have different API key. If they are reusing API keys, then of course we can rate limit them because they are reusing API keys. But they are not reusing API key. They have 10 different API keys, then we can easily track them. Okay, so here the first thing we'll do is we'll get the API key. So here we'll say request dot header, come on, x, oops, sorry, X API key. This is one of the standard header format. Okay, so I'm gonna just mark this. I'm using TypeScript, so I have to provide some types here. So I'm gonna just say undefined. I might have to stop my Docker container. It's slowing my system down. Okay, so now what happens is we'll check if the API key does not exist. Right, if the API key does not exist, we'll just return, we'll say return res dot status 401. We'll just say unauthorized. We'll just send unauthorized. Okay, because if the API key doesn't exist, we're not allowing them to use the service. Okay, then what we would do is we would actually use Redis to to help us with this rate limiting. What exactly is Redis? Redis is like an in-memory database. Usually we call that as a caching. Okay, so why are we not using MongoDB or SQL? Guys, you have to think about this. SQL and MongoDB are meant to store data, like huge number of data, your application data and everything, and their speed is a bit slow compared to Redis. Okay, in our case, when you're dealing with rate limiting, your request response should be faster, read rate response should be faster, because rate limiting data is like what, very simple data, right? One or two, increment it, decrement it, right? Get the number, total number of requests, something like that. It should be very fast. Don't use database for this. For database, you have to create schema and all those stuff again and again. Whereas Redis, right? Redis is like key value based. Give a key, give a value. That's all. Nothing else. No schema, nothing. Okay, so it makes really perfect companion for us for this particular problem to solve it. Okay, now what I'm going to do is I'm going to say response, we call it we call it response. Okay, and we'll say await Redis client. What is this Redis client? Where is this coming from? So this Redis client is something that I've set up here, redis.ts. So where I'm importing Redis from the npm package, and I have this Redis URI. Okay, if you don't have this Redis URI, I suggest you create one from this particular site, upstash.com. Go to upstash.com, create your own Redis instance. Okay, and then add the URI here. Okay, and then if I come back, where is that? Yeah, if I come back, you can see at the end I'm saying Redis client.connect, and once it is connected, I'm running the server. Okay, so now here we'll say Redis client.increment. Okay, incr increment for API key. So for API key, we're incrementing. If it's 0, it will say 1. Okay, nothing else. API keys will be the key. The value will be 1, 2, 3, 4, something like that. Okay, and then here I'm gonna check. Okay, if response is equal to 1. If it is equal to 1, what I'm gonna do is I'm gonna say expire this. Come on, my system is a bit slow today. Expire this, expire this after default TTL. I'm going to say default TTL. So what exactly is this default TTL? This is a simple constant I have in constant.ts. So it says 60, basically 60 seconds, and default quota is 10. So here I'm allowing 10 requests per minute. Okay, I'm following the sliding window. You can change this to like 8600 seconds, that's 24 hours. Okay, you can change this to 1 hour, right? Let's say 600 I don't know, I'm really okay, I'm bad at math, I'll accept that, but you can change this seconds. If you want it hour, days, 2 days, weeks, just change the seconds here, change the number of quota here, that will take care of everything. Okay, so now default TTL is 10 or 60, so every 60 seconds we'll expire the count, we'll reset it to 0. Okay, and then if in case the response number is greater than the default quota. So what is default quota? 10. If the request for the given minute, let's say in this present minute, right? If the given response, let's say more than 10, then we will actually return, okay, we'll return a error saying that res.status 429, okay, it's like a request allocated resources exceeded, something like that. Okay, and we'll say JSON error allocated quota exceeded, or you can say allocated request quota exceeded, something like that, some message. Okay, and now you can see it's done. We're able to throw a message saying that hey, you're done with your request, bye bye. Okay, so this will take care of everything. Okay, and while sending it to the user, you can also send it to them. Well, we'll do one thing, we'll say user, so we'll send the user's data here, and then we'll say TTL, what is the remaining TTL. So for that actually you have to we'll say const TTL, you have to set up here await Redis client dot TTL API key. Okay, so this will give the time to live. So basically, let's say we are expiring for every minute, no? So if it's only 30 seconds, it will say 30 seconds. That timing we can get it from here. Okay, so here I'm going to return the TTL of the user and the available quota as well. So I'm going to say quota. Okay, so default quota minus response. Okay, minus response. You can change this name as well. You can say some used quota or something like that, but I'm just going to keep it response. So now if I stop and restart the server, okay, you can see if it says app running, then the Redis client is successfully connected. This might take a second. Okay, strict mode. Okay, what happened? Some JavaScript error. Getting some errors, guys. Yield. Okay, it says here is not able to properly connect. Something is wrong here. Alright, I found the issue. The issue is really silly. I didn't actually set up async here. I'm misusing await here everywhere. That was the issue. When compiling, it had some issues. And there was one more issue that we should use API key here, specify the key and then the default ETL so that it can expire. Okay, now if I run pnpm dev, it should be able to start the server. And here we go. Come on. Yeah, there we go. Server is done. So we'll go copy our API key. Here we go. And we'll open up headers. We'll say X API key. Okay, and then pass the API key here and then send the request. You can see we have users and then we have 60 seconds and we have 9 quota left. We'll spam this server. 8 left, 7 left, 6, 5, 4, 3, 2, 1, 0. There we go. It says allocated quota exceeded. If I send again, it says exceeded. I can keep trying until I complete the 60 seconds limit. So once we complete the 60 seconds limit, we'll be able to proceed to the request again. So I keep on saying that. It says nope, you can't go. I could have returned that TTL here as well, right? So I could have known like what is the remaining seconds. So well, meanwhile, I can just explain like how we can proceed from here. So we were able to handle one edge case, that is IP addresses. Okay, the second edge case was handling this TTLs and everything. We were able to do that. Okay, moving on, you can simplify this even more. You guys can have like a rate limiting middleware like this. Just copy paste the same code here, have it as a middleware. Okay, and send the quota and TTL as a request object. Okay, and what you guys can do is you can reuse it. So here I can just remove this. Oops. Yeah, remove this from here, all these code, and reuse this. So here I have copy pasted the same code to that particular middleware, right? I can just say rate limiter here like this. Okay, so this will be called as a middleware. So I can just add it to here as well. Okay, and restart the server, and basically this will allow us to reuse the entire rate limiting module. Okay, and if I send the request, okay, still starting the server. Hold on, few minutes. Just stop. Few minutes. Right, there we go. Oh, we got some error. TTL is not defined. Ah, yes, sorry. So this will be request.ttl. Okay, and this will be request.quota. Request.quota, because we're sending this request.ttl and quota from here. You can see, right? Request.quota and request.ttl. We're sending it from there. Now if I restart the server again, I didn't set up nodemon, guys. I know if you guys thinking about it, I didn't set up nodemon, I'm sorry. And then I can send the request again to get the, yeah, there we go. So we're able to get the same thing. You can see TTL 20, 80, 16. So it's expiring. There we go. There we go. Done. Expired. So we have around 5 seconds left to get another set of request quota. Done. There we go. 60 seconds, 58, 70, and you can see, right, when I did the first time, it started from like 20 or something, because the Redis was able to remember the my particular quota. See, we're expired. Done. We have 44 seconds left to get another quota. That's how you do it. Okay. Use middlewares. Okay, so that you can reuse it, and then use API keys, and don't use IP addresses unless and until you don't have an option. You can also do this. If the user is using API key, give them like 100 requests per day or 100 requests per minute. If they're not using API key, then use IP address as a fallback to track it, and give them like 20 requests. Tell them register for API key to get more bandwidth. If not, we'll use your IP address so that you only get like 20 requests per time, so that they don't spam. Okay. So that's all, guys. Thank you so much for watching, and if you guys have any doubt, you know what to do. Okay, just let us know in the comments, or you can drop a message on WhatsApp group or Discord, anywhere. Okay, thank you so much. Take care.